In this lab, a brass dog bone specimen will be subjected to a tensile test using the Instron 8516. The specimen will be progressively loaded through the linear elastic region until the strain is approximately 15% and then unloaded. Note the plastic deformation of the unloaded specimen. A secondary test is started which reloads the specimen and continues until fracture occurs. Each lab section is provided a single brass specimen. Measure the width, thickness, gauge length, and overall length of the dog bone specimen using the digital caliper and micrometer. For replication, have several students measure the specimen and record on the front board to share with the entire lab section. The lab has two Instron testers with a central computer console to interface both machines. For the tensile test, we'll be using the 8516 on the left. Press button number 1 on the KVM switch and then turn on the left computer. To power up the Instron, toggle the switch located at the rear of the controller towards the top. The Instron will take a few minutes to boot up. When ready, RAM position and load should be displayed at the top with the units of millimeters and kilonewtons. Also, you'll notice a flashing green LED which indicates the load cell must be calibrated before proceeding. Before calibrating, verify the load cell is unloaded with the grips empty. Press the setup button below the flashing green LED. On the lower console, press the soft key sequence Cal, Cal, Auto, and then Go. The LED will blink rapidly during calibration. When calibration is finished, the LED will glow steady. Next, the load cell must be balanced or zeroed. As before, press the setup button for the load channel. On the lower console, press the soft keys for Cal, Cal, and Balance. The load display should now read about 0. Press button 1 to start the hydraulic pump in low pressure. Wait several seconds before pressing button 2, which jumps to high. Jog the RAM to the starting position of -40 millimeters using the control wand. The up-down buttons are for coarse movement, while the thumb wheel allows for fine adjustment of the RAM position. Try to get as close to -40 as possible. Install the specimen in the grips and tighten until firmly snug, which imposes a preload on the specimen. Be careful not to over-tighten, which may damage the grip. Close the guard door when finished. The default test definition should be fine. However, to edit, press the Position Waveform button. On the lower console, press the soft key for millimeters and enter the desired travel using the numeric pad. Similarly, press the soft key for millimeters per second and enter the desired speed. Turn on the Strain Master controller using the front button. Wait for the blue indicator to glow steady. On the desktop, double-click the Diviz 10 icon. The hardware is automatically initialized on startup. Once loaded, click the New Project icon. In the pop-up menu, name the project by section number, in this case, Section 2. Then use the pull-down to set the type to strain. Click OK when done. The new project should appear under the workspaces. Remove the lens cap and turn on the LED light panel using the rear switch. In Diviz, select the recording icon. Images should automatically be streaming, otherwise click the camera icon. Under the Image Tools, toggle the crosshair button to display a red overlay. Use the XY stage to center the image by adjusting the lateral camera position. Focus may be adjusted using the lens ring or the XY stage for finer adjustment. Area of interest reduces the image size around the feature of interest, which dramatically reduces the storage size. Click the AOI icon, which opens up a new window. Select the Center Alignment tool. Then use the mouse to click and drag a node to reduce the window width around the dog bone specimen, leaving a small buffer. Select the Accept button to return to the previous window. Scaling defines a conversion factor between image pixels and millimeters. Select the scaling icon from the calibration submenu. Click the camera icon to capture a single image of the specimen, and then use the zoom tools for a close-up image. Verify the radio button for distance scaling is selected, and then click the horizontal scaling tool. Use the mouse to place the guidelines on opposite edges of the specimen's gauge width. Now enter the mean value from the student's measurements in the distance field. Then select the Accept button at the bottom. In the pop-up window, select OK to activate the new scaling factor and return to the home screen. Return to the recording screen. Verify the camera exposure time is set to 2.5 milliseconds. Next, verify the analog-digital converter range is set to plus or minus 10 volts, and both channel 1 and channel 2 are enabled with the checkbox. Inspect the configuration using the ruler icon. For channel 2, set the displacement offset to the current position of the instron, but with the opposite sign to cancel out the measurement and display 0. Alternatively, click the Auto Offset button to automatically set the offset using the current displacement signal. Expand the digital display using the small arrow above the image. We'll add 2 displays for load and displacement. Click on the Add button at the far right. In the pop-up menu, select Device Data. Do this twice. The default is channel 1 or load. Set both displays to show the average value. Reassign the second device to display channel 2 or displacement. The display should now show time, load, and displacement. Verify the image rate is set to 10 Hz. The recording length should be set to around 3,200 images, which is based on the Instron test settings and the devised image rate. The noise floor will be used to determine the resolution error of the strain measurements. Set the recording name to noise floor, which will appear in the project tree afterwards. Click the recording button. Continue to capture images of the unloaded static dog bone specimen for about a minute. When a minute has elapsed, click the Stop button. The variance in measured strain defines the strain resolution error. Set the max position limit to automatically unload the specimen at 15% strain, which occurs at approximately 15 millimeters displacement based on previous testing. Press the Max Position Limit button in the upper console. Set the limit to negative 25 millimeters, which is 15 millimeters displacement. Using the soft keys, set the action to unload the specimen when triggered. Finally, toggle the limit on. The LED should be on. The tensile test is ready to run.
Reset the recording name to the default by clicking the X icon on the right. A new name may be optionally entered. When ready, click the record button. Once images begin streaming, press the start button on the Instron. Monitor load and displacement throughout the test.
At -25 millimeters, the Instron will automatically stop and unload the specimen. In DIC, click the stop button to halt video streaming. The red LED above max position limit will be flashing, indicating it's been triggered. Press the max limit button and use the soft key to turn the limit off. Next, press the load protect button and again use the soft key to toggle off. We're ready to restart the test.
When ready, click the record button. Once images begin streaming, press the start button on the Instron.
After fracture, click the red stop button in DIC. Then press the stop button on the Instron. Click the back button to return to the home screen. Notice the 3 recordings in the project tree: noise floor, cold work, and then fracture. Exit DIC by closing the window in the upper right corner. Remove the test specimen from both grips. As a sanity check, piece together the fractured specimen and measure the overall length and approximate gauge length. Use these measurements to compare with the calculated overall strain. At this point, the students should return to their workstations to perform the analysis. Following a stop event, the Instron must be reset by pressing Function, then Stop Reset. Jog the RAM to the start position of -40 millimeters. Shut down the hydraulic pump by going to low pressure. Pause a few seconds, then off. Shut off the Instron if you're the last lab section of the day. Finally, shut off the light and replace the lens cap.